And welcome to Master Talker online class. In today's video, we'll be talking about logic, algebra or proposition and argument. Please, if today is your first day of watching our video, please consider subscribing. Okay. In this topic, we are going to be studying the rules of logic. Okay. Valid arguments to make sound conclusion. Then logical reasoning. Okay. The way it is usually described. Now, the first thing we need to look at is proposition. Proposition. Now, in proposition, we say that a statement is a sentence or a group of words that is either truth or false, but not both. Okay? Proposition. What is a statement? A statement is a sentence or group of what? Words that is either truth or false. Please write it down. Okay, that is either what? Truth. Before we say that something is a statement, it is either truth or false, but not both. Okay, so example of statement is Anambra is in Ghana. Anambra is in Ghana. Okay, if you look at that, you see that it is not true, but it cannot be true and false. So the next one is that what? Lagos is the capital of Accra. You see, another one, Accra is the capital of Ghana. So all these things are statements. I can equally say that 9 minus 9 is equal to 15. Okay, they are all statements. These can never be true and false at the same time. So it's either that is true or false. So if you look at this one is false. Okay, so that is that. Then they now say each of these expression above is either true or false, but not both. Thus, they are statements. Okay, so the statement is either is what? A sentence that is either true or false. So don't forget that. If I say what is your name, what is your name is not you cannot say what is your name is either truth or false. So it is not a statement. Come here is not a statement. You cannot check if it is true or false. Okay. So and so on and so forth. So now let's talk about another thing. Let's talk about when two or more statements are joined together, okay, by the logical connection, like by the logical connection and or okay. When two or more logical statements, okay, are being connected. When two or more statements are being connected. Don't forget what is a statement. A statement is a sentence that is either truth or false. Okay. Then I'm telling you now, when two or more statements are connected with and, they are connected with and or connected with or, like this. Okay. They are called a compound statement. They are called a compound statement. Okay. An example to that is that Kingsmatics is handsome. Okay. Then another one, Kingsmatics is rich. Now, if I want to combine these two, I will say that what? Kingsmatics is handsome. And rich. You see, so this is what? A compound statement. Why? Because it is being connected with what? And I can equally say that Kingsmatics is handsome or rich. So whenever they are being connected with what? And or, they will say that it is what? A compound statement. We say that it's a compound statement. So now let's look at logical symbols and notation. Logical symbols and notation. Logical symbols and notation. Okay. Now the first one we're going to look at, we are going to say that we use small letter to denote statement. We use small letter to denote statement. For instance, we can say that let P, small letter P, be what Kingsley, Kingsmatic, sorry, Kingsmatics is handsome. Okay, then we now use small letter q to denote that what Kingsmatics is rich. Okay, so we use small letter to represent statement. That is the first thing you need to note. Okay, the first thing you need to know is that we use small letter to represent statements. Then another thing you need to know is that we use the symbol this. We use the symbol this to represent and. So this stands for and. This stands for and. Okay. So example, if I want to combine this one, I will say that P and Q. That is the statement that said that what Kingsmatics is what handsome and rich. Okay, so we use this statement to represent and. Then we now use this one, and it is called conjunction. Yes, this is called conjunction. Another word for and is what? Conjunction. Okay, then the next one is we use this one to stand for or. This one stands for or. Okay, and it's called disjunction. 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 So if I say P disjunction Q, it means that what Kingsmatics. Remember, we are still using this example. Kingsmatics is handsome or rich. Okay, so that is that. The next one you look at is negation. Okay, negation. So we use this like this, something like this, negation of P. Okay, we use it. This is to stand for the negation. So this thing stands for negation of P. Negation of what? P. Which means if I do this P, it means the negative of this. Since I say Kingsmatics is handsome, it means that what Kingsmatics is not handsome. The negative, Kingsmatics is not handsome. So we cannot use it as Kingsmatics is ugly. It's not the same thing. Okay, in mathematics, opposite of handsome is not ugly. Opposite of handsome in mathematics is not handsome. Opposite of ugly is not ugly. So please note that. So note that, very very important to note. So the next one, number 4, the next symbol number 4 we need to know is that so this is 1 2 3 4. This is 3 and this is 4. So this one is 5. So number 5 is that the true or falsity of a statement is called the truth value. Okay, the truth or falsity of a statement is P. Okay, is called a truth value. Okay, a truth value. The truth value of P is written as T, capital letter T. The truth value of P is written as capital letter T. Okay, and written as F if P is false, and written as F if P is false. Okay, so now the next thing we're going to look at is truth value. The truth value of compound statement. The truth value of compound statement. Please, all these things I wrote down is very very important to note. Okay, then when we start solving calculations, it will now be making sense. So the next thing we are going to look at is the truth value of compound statement. Truth value of compound statement. Okay. Now they say that if P is true, number one, T1, the first one said the first truth value you are going to look at for compound statement is that if P is true and Q is true, then P and, I hope you remember that this thing is and, P and Q is equally truth. Okay, if P is true and Q is true, then P and Q is true. Okay, otherwise false. Now what do we mean by that? Before now, and look at how I used to remember it. Okay, this thing is pointing to the heaven. Before we can go to heaven, the both of us must be truthful. So if P is truth and Q is true, that is when we can say that both of them will not be true. But once one person lies, we have scattered the going to heaven. We are not going to heaven again. So it cannot be true. Rather, it's going to be what? It's going to be false. Okay. So thus P and Q is true if and only if. So thus P and Q is true if and only if. IFF means if and only if. If and only if P is true and Q is true. So that is the only condition that will make these two people to be true. So the second true value you need to know is if P is true, okay, if P is true, comma, or Q is true, okay, or both is true, okay, or both P and Q is true, then P or Q is what? Is true. Now this one is pointing to hell, and the hell, once one of them is does that thing, then it goes. Okay, if one of them is true, then it is true. If one of them is false, then it is false. In fact, at least one of them has to be true before it will not be true. Okay, otherwise false. That's just it. Okay, as far as it's pointing this, so we have that P or Q is true once one of P or Q is true. Okay, in this one is that once one of them is true, the answer is simply truth. Okay, the only way the answer will be false is when both of them are false. But once one of them is true, automatically the answer is true. But here in this one is that both of them has to be truth before the answer will be true. Okay, so that is how you have to know that. So the next one is that T3 said that if P is true, automatically the negation of P must be false. Then if P is false, then the negation of P is equally false. Okay, so that is what you need to know. In summary, let us summarize it using a truth table. Let's summarize it using a truth table. Now, I'm having my P. This is my P and Q. Then this is P and Q. This is for conjunction. Don't forget that conjunction is and if they are two like this, you're going to have truth, false, false, false. Okay, that is if there are two like that. Then the other one will now be truth, false, truth, false. Okay, that is how to arrange it. If there are two like this, I will still tell you what happened when there are three, but this one and there are two, it is simply truth, truth, false, false. Then the other one will now be truth, false, truth, false. But if it is just one single, it's going to be truth and false. Now I told you that truth, truth, the only reason both of them can be truth is when both of them are truth. That is when they can go to heaven. But look at this, both of them being false, okay, false. Sorry, one person being false, okay, false. If both of them are now false safe, okay, you must be false. So that is that. So the next one we'll look at is disjunction. Disjunction. Now in disjunction, don't forget that the symbol is like this, and conjunction, the symbol is like this. So we have the same thing here. So we're having our P and our Q. Then P disjuncts Q. Okay. So we have our truth, truth, false, false. Then here will now be truth, false, truth, false. Okay. And this one said once one person is truth, that is when they will not be truth. Okay. Once one person is truth. Is anybody truth here? Yes, truth. Is anybody truth here? Yes, truth. Is anybody truth here? Yes, truth. Is anybody truth here? No. So it will not be false. Okay. So that is that. So for negation, let me do it here. Negation is just for one person. Okay. So I'm going to have P, then negation P. So I'm going to have only truth and false. I told you for one person it's just truth and false. So negative of truth is false and negative of false is truth. As simple as that. Okay. So that is that. Then from the truth value above, we can see that, for instance, that if P is true and Q is false, then the conjunction of P and Q is false. Okay, I've explained that. So now they say that a statement P is called a variable. Okay, a variable if its truth value is not known, and a constant if it is known. Okay, so they say that a statement P is called a variable. It is called a variable. You know, variable and constant. It is called a variable if the truth statement is not known, but it is a constant if it is known. So the truth value of a variable can be truth or false. Okay, then the compound statement M, which is PQR, is called a proposition if the substatement PQ are variables. So we can obtain the truth value of any proposition for each of the truth value of the substatement, and hence we can construct the truth value of a proposition. Okay, we can construct a truth value of a proposition. Oh, all these things are just simple statements. Okay, so let us do some calculations. They say construct example 1 said construct the truth table, construct the truth table of, okay, of the proposition P or negation of P or negation of Q, P or negation of P. Okay, don't forget that this thing means or. So what do we do? Look at what to do. It's very, very simple. First of all, I need my P, I need my Q, then I need the negation of Q before I will now need P or negation of Q. So that is that. So don't forget the way we do it. This is truth, false. Why this one will not be truth, false, truth, false. And the negation of this is false, negation of this is truth, negation of this is false, negation of this is true. So, and I told you that in all, once one person is saying the truth, automatically they will both the answer is truth. Okay, so this is the truth, false, truth, 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 false, 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 truth, truth. Okay, so that is just the what is it called, the truth value of that. Okay, now they now say let P be the statement. Okay, another example. Another example said let, example 2, they say let P be the statement. Let P be the statement, he is rich. Okay, Q be the statement, he is handsome. Okay, then and R be the statement, he is intelligent. These people might be referring to me. Intelligent, not even might, they are referring to me. So then I say give the verbal statement, give the verbal statement of each of the following. Okay, they say I, P, and Q. P or R. P and negation of Q. Negation of P and Q. Negation of P and negation of Q. Okay, now solution. If you look at this one is P and Q, which is he is rich and handsome, because this is and he is rich and handsome. So the other one is now he is rich or intelligent. He is rich or intelligent. This one is what? He is rich but not handsome. He is rich but not handsome. Why this one is that it is not true. Look at it. It is not true that he is rich and handsome. It is not true that he is rich and handsome. Okay? So why this one is that he is not rich and he is not handsome. So that is that. Or he is neither rich nor handsome. Okay? He is neither rich nor handsome. So let us do another example. Example number 3. Example number 3. So example 3 said let P be the statement, he is dead. God forbid. He is dead. And Q be the statement, he is forgotten. It's not possible. Be the statement, he is forgotten. He is forgotten. Then use symbol. Use symbol to express. Use symbol to express I. He is dead, but not forgotten. But not forgotten. I. Shit. Okay, sorry for the interruption. Okay. I. it is not true. It is not true. It is not true that he is dead. It is not true that he is dead and forgotten. I. He is dead or he is forgotten. He is dead or he is forgotten. Okay, solution. So the first one, he said he is dead but not forgotten. He is dead is what? Is P, but not forgotten, and he is not forgotten. Okay, that is that. So I. He is not, okay, it is not true that he is dead and forgotten. First of all, he is dead and forgotten. Then it is not true. Negation of the two. Then I. He is dead or he is forgotten. He is dead or he is forgotten. So that is that. So let us continue with our examples. So okay, let's go into the algebra of proposition. The algebra. The algebra of proposition. Okay, now we want to prove some propositions. The first one said prove that the negation of P and Q is equal to the negation of P or the negation of Q. Okay, we want to prove this. So in proof, look at the way we do proof here. In proof, we have, in fact, you are going to put everything here. You have your P, you have your Q, you have negation P, negation Q. We now have P or Q. First of all, you now have the negation of this one, negation of P or Q. Then finally, you now have negation of P and negation of Q. And negation of Q. So don't forget the way we state this one. Truth, false, false. Okay, why this one is truth, false, false. Then negation of P is now false, false, truth. Negation of Q is false, truth, false, truth. And then P or Q. And I thought that or means that once one person is truth, then it is true. So P or Q. This and this is true. This and this is, one of them is true. One of them is true. Both of them is false. So the next one is now the negation of this one. Negation of truth is false. Negation of truth is false. Negation of truth is false. Negation of false is truth. Now this one is now negation of truth and negation of false. And means that two of them must be truth for it to be truth. So not again. That's Nigeria for you. Okay, so let us continue. Sorry about that. So negation of P or negation of Q, and I told that for and is facing heaven. For and both of them must be truth for it to be truth. False, false. false, false truth, false, truth false, false, truth truth, truth. And if you look at that, you see that this and this are the same thing. So therefore negation of P or Q is the same as negation of P and negation of Q. Proved. Okay, so that is how we do the proof. So let's do another proof for you to understand it better. So let's do another proof. Okay, let's talk about some algebraic proposition. Number one we're going to talk about is tautology. Okay, they say that a proposition, write that a proposition P, which is which is P Q R dot dot dot, okay, is said to be a tautology. Is said to be a tautology. Okay, is said to be a tautology if it's always true, no matter the truth value of the variable. Okay, they say that if it is always true, it is tautology if it's said to be truth. It's said to be tautology if it is always truth, no matter the truth value. I hope you know that truth value does not mean that is truth. Truth value is just the value, and truth value can be truth or false. So it is tautology when we have true everywhere. Then you call it what? Tautology. That is number one. Number two is contradictive. Okay, we say that a proposition P, which is capital letter P, which is what? P Q R dot dot dot, okay, is said to be a contradiction if it is always false. So this is just the opposite of this one. Opposite of tautology is contradiction. Okay, contradiction. So the proposition is said to be contradiction if it is always false. So once it is always false, we say that it is what? A contradiction. Example. Let P be the statement okay. Example, let P be the statement. Let P be the statement. Let P be the statement. It is hot. Okay. Then negation of P is the statement. It is not hot. It is not hot. Okay. Thus P or negation of P is always true. Then it is a tautology. Okay. On the other hand, P and Q is always false. That is, therefore it is tautology. Therefore it is contradiction. Therefore It is contradiction. So let me explain. They say that P is a statement, it is hot, and then the negation of P, which is what? It is not hot. If you say that it is hot or it is not hot, it is always true. Yes, now it's always true. So it can either be hot or not hot. Are you getting it? Then it is called what? A tautology, because it is always true. But if you say that it is hot and not hot again, you are contradicting yourself. So it is what? Contradiction. So let us draw a truth value of that. A truth table of that. Let us draw a truth table to illustrate that. Okay? We say that P negation of P. So I told that if it is just one, it's just truth and false. And negation of this is false. Negation of false is what? Truth. So if you now have P and negation of P, okay? And I told that for something to for it to be true, all of them must be truth. So this and this is false. This and this is equally false. And I thought that if the truth value of them is false everywhere, then it is called what? A contradiction. So let us check the other one. Okay, no need of drawing this one again. Let me just add it. This is P or negation of P. And I told you that for all, once one of them is true, then the answer is truth. Truth. False truth. You see? And when it is truth everywhere, then it is what? A tautology. Then it is a tautology. So let us look at another one. So do this as an assignment. Prove that the negation of P and Q is something as negation P or negation Q. So draw your own truth value, truth table, okay, to prove that. Use your truth table to prove that this is this. Then drop the answer on the comment section. Then the next one. So we now have the law of proposition. The laws of proposition. The laws of proposition. Okay? So let us continue. The first one is idempotent law. Okay, idempotent law is simply saying that P and P is still P. Okay, and the P or P is still P. That is idempotent. Number two said commutative law. Commutative law means that what? That P or Q is certain as Q or P. Okay? And the paper said P and Q is certain as Q and P. Then they are commutative. Commutative means that 2 plus 3 is certain as 3 plus 2. That's the meaning of commutative. Okay? Number three said associative. Okay? Associativity said that what? That P or Q then or R. Okay? It's something as what? It's something as saying P or Q or R, like this. So they can associate to each other. Then the B part say P and Q and R is something as saying P outside and then Q and R, that they are the same. You can prove them with your truth table. I've taught you how to draw a truth table. So you can prove them. Then the next one is distributive law. Distributive law. You know that in distributive law, look at that. Distributive number 4. Distributive. In distributive law, we are having that what? That P or Q and R, okay, is the same thing as P or Q and P or R, okay, and that is A part. Then the B part said P and Q or R is the same thing as P or Q and P and Q or P and R okay. So that is that. Number 5, identity. I clean here. Number 5, identity law. Identity law is P or false is the same thing as P or truth is the same thing as P, okay. P or P and truth is the same thing as what? P. Then P and false is the same thing as what? P, okay. That's identity. Identity means that like you get yourself back. That is like 2 times 1 is equal to 2. So 1 is an identity element for multiplication. So you get yourself back. And then for addition, 2 plus 0 is still 2. So 0 is an what? An identity element to that. So the next one, number 6. Number 6 said complement law. Complement law. The complement say that P or negation of P is truth, and negation P is still P. That is for A. Then for B, P and negation of P is truth, is false, and negation of truth is false, and negation of false is truth. So then the last one, number 7, is De Moivre theory. De Moivre law. Okay, De Morgan's law. De Morgan's law is the one we proved the other time, that the negation of P and the Q is simply, when you want to share it for them, that this one will turn negation P or negation Q. Then negation of P or Q, when you want to share it, this one will turn negation of P and negation of Q. That is called De Morgan's law. Okay, then let's go to duality principle. The duality principle. Duality principle. Okay, I can clean here. Okay, so duality principle, they say the dual of a proposition identity P1, which is equal to Q1, is the proposition identity P2 equal to P2 obtained from the first identity by replacing all the and with or and all the or with and. Example, the duality of this. The duality principle states that given a proposition identity P1, which is equal to Q1, the duality is the propositional identity. The propositional identity. Okay, let's look at this. Simplify the following. Example, they say simplify the following. simplify the following, and they gave I. They said the negation of Q or negation of P, okay, and okay, or Q and P, okay. So draw the truth value. Draw the truth value to know what it will give you. Okay, draw the truth value to know what it will give you. Okay, so it's an assignment. You can draw the truth value to know what this statement will give you. You need to get this one, then anything you get here, this and this, so to know what it will still give you. Okay. Okay, in fact, prove that this thing is simply P. Prove that it is P. Let us just do it like this. Prove that it is P. And then conditional statement. A conditional statement involves two statements P and Q. It is of the form if P then Q, or P implies Q. Okay. Now in the implication, if P then Q, we're not talking about conditional statement. Conditional statement, and that is the last thing. I think that's the last thing we're going to talk about here. Then we are done with this topic. That's the last thing we are going to talk about. So conditional statements, we use implication. For example, Amaka will go to market. It will rain today. If you want to make it conditional, to say that Amaka will go to market if it rains today. So the condition for her going to market if there will be a rain, okay, and that is a conditional statement, and that is if then this, or it implies that Amaka will go to the market if it rains. So that is that. And in implication, how do we do implication? Implication said that once one of them is okay. Look at implication here. P, let's do the truth table of implication. Look at the truth table of implication here, so that you will get that Q, P implies Q. So we have truth, false, truth, false, truth, false. Why this one is truth, false. Now in implication, depends on what is started with. If they are the same thing, then automatically the answer is what? Truth. Once they are the same thing, the answer is truth. They are the same thing, truth. But if they are not the same thing, you consider the one that comes first. Then this thing means if P then Q. So P is the main man, the person that comes first. Amaka will go to the market, should be Q if it rains. So the main man is if it rains. So if it is true here, if true comes first, then it will be true. If false comes first, then it will be false. But when they are the same thing, then the answer must be truth. Okay? If they are the same thing, the answer must be truth. Please take note of that. If they are the same thing, then the answer must be truth. So we can take another important one. Okay, another one is this one is called the conditional statement, right? The conditional statement. Then the conditional statement is in two forms. The first one is that is if this then that, but the other one said if and only if. That one is if and only if. That is called the contraposition. The contraposition, and that is the last thing we are going to do. Then for the contraposition, look at how we represent it. For contraposition, we present like this. P, the arrow is facing like this, two of them. Okay. For contraposition, is simply that it is only truth when both of them are the same. That's all. That's all the difference between this one and this one. In this one said that it is truth when both of them are the same. So these two are the same truth. These two are the same truth. If not, it will not be false. So that is that. So you will take note of that. I think we are okay. We have done enough. So may the peace of the Lord be with you. Okay, argument. They say Okay, we have not done argument. Argument. Okay. They said an assertion that a set of proposition P1, P2 up to Pn implies a proposition Q is called an argument. Okay. So the major thing they will ask you is to prove that this is this, prove that the other one is the other one. Okay. They say that example one said the following argument is a fallacy. Now in an argument is of two types. It can be a fallacy. They say when an argument is true, it is said to be a better valid argument. When it is false, then it is a fallacy. Okay. When it is true, it is what? A better valid argument. But when it is false, then it is a fallacy. When it is false, then it is a fallacy. So that is that. So thank you very much for watching. I think we have done enough. You can share and subscribe.